Here we've depicted an unlabeled sine graph. Got an axis right through the middle in the vertical sense, and we got a y-axis here. Okay. Now we haven't put an x-axis on this graph, or horizontal axis, because I don't have an arrow on this axis, and as it turns out, I'm not going to use this for the horizontal axis of my graph, for reasons that we'll see in a minute. Well, here we are. We want the y scale to go from 15 to 25 as the graph goes through one complete cycle. How are we going to achieve that? Well, we can easily depict those quantities. Y is going to go from 15 to 25. Meaning, of course, that this horizontal line here represents y equal to 20. Now that's not consistent with the way we've constructed sine graphs up to this point. Of course, you know, our construction here is fine, but this is not consistent with the kind of labeling we've used. The labeling that we've used so far, we've had some number up here and the negative of that number down here, so that the sign goes from some negative number to a positive number of equal magnitude. The value of the sign goes from one of those numbers to the other. In this case, though, we're going from some number to some other number, and y equals 0 does not correspond to this line. And remember, if we construct our sine function, y equals 0 seems to be identified with this line. So what are we going to do about this? Well, what we're going to do about this is we're going to regard this graph as the graph of a sine function constructed in the usual manner, but with the axis down here someplace, so that we have to raise the function from wherever it is in our initial construction to this position. Excuse me. Okay. This distance is 5 units. If I go down 1, 2, 3 times this distance, that puts me about here. That's where y equals 0 would be. Then if the amplitude is 5, that means that if we were to construct our function down here instead of up here, we could put our axis here, because our axis needs to be actually at y equals 0. We have y equals 5 here, y equals negative 5 here. And we can construct then a parallel graph. Of course, we're not going through the compass and straight edge construction, but by making a reasonable sketch, we can at least represent the graph we'd have if we did a careful construction. So that this graph has exactly the same shape as this one and the same dimensions, but it's lower down where it needs to be if this is going to be our horizontal axis. Okay, so our horizontal axis, let's just do a graph of y versus theta. So this graph is the graph of what? Well, from what we've seen before, you see that this graph is a graph of y equals 5 sine theta. And implicitly, if theta is our phase, then we've got 2 pi here. Now we don't actually have to have 2 pi here. We can leave this unlabeled. Okay, so how are we going to get the function for this graph? Y equals what for this graph? Well, every point of this graph has to lie 20 units above the corresponding point of this graph. So if I was to draw a vertical line representing our theta coordinate or our horizontal coordinate, this this point up here would have to be 20 units above this point, because of course our axis of, it's not actually an axis of symmetry, but our central axis, central horizontal axis for this sine function lies 20 units above this one. Everything else is the same. So that this has to be then sine of theta plus 20. So if we take a given value of theta, plug it in here, find the sine of that value, multiply that by 5, we get this y value. For that same value of theta, if we take that value of theta and I got careless here. Hopefully you saw that before I did. It should be y equals 5 sine theta. Okay. So if we take our value of theta here, plug it in, we get the value of the sine, multiplied by 5, we get the same thing that we got down here. Then we add 20 to it to raise this point up 20 units, and now we have the y coordinate on this graph. So this is how we vertically shift a graph of a sine function, so that y equals sine of theta plus k. Let's just do it like this. Graph of y equals sine of theta plus k shifts the graph of y equals sine of theta k units in the y direction. And k could be a negative number. If we add negative 10, what's that? We get sine of theta plus negative 10. Well, whatever the sine of theta is, whatever we get when we put theta in, if we do this, if k is negative 10, our y value will be 10 less, which means that we would take a sine function and lower 10 units. Now, this isn't just a y equals sine theta function. This is y equals 5 sine theta. That's of the form y equals a sine theta. If we take the graph of y equals a sine theta plus k, that's going to shift the graph of y equals a sine theta k units in the y direction, just as the case here. Okay, so this is what we mean by the vertical shift of a sine graph. In general, if we have some multiple of the sine of theta and add k to it, we get the graph of, well, the graph of this function will be k units vertically shifted relative to the graph of this function.